Right. Now, my formal lecture today will not be that long. I was just essentially going to do the rest of the evens that we didn't do last time. Okay, so we're over here. I said 1 to 16 all, but I was going to end up doing just about all the evens. Okay, so my formal lecture will be done not that long, at which point we can start asking for questions in review for the test today and tomorrow. Okay, so we'll have maybe 1.5 days to do that. Okay, so I'll knock off the rest of the evens, which I believe I got up to 10 last time. So I'll do a 12, 14, and 16, I think. Then I'm done. So you be prepared for questions and answers on anything here. Maybe you want me to do some of the odds from 5.4. And same thing tomorrow. Okay, so I'm giving you all of tomorrow and some of today. So our exam, we're over here now. I didn't mark off this. So we're here the 18th. Okay, so our exam 5 is Friday. Okay, and then after that, we just have one more test, just the 4 sections. And we have, I'll say 2.5 weeks. I mean, it's 3 weeks, but we get, Thanksgiving holiday, 2 days off, and then so forth. So I'm going to aim again for the last regular test to be Thursday, December the 10th. If it changes, I'll let you know. And Friday, return exam 6, that language was meant to be if we had met face-to-face, since I didn't know we were not meeting face-to-face, but we can just make this as a review day to review for the final. Okay, reminder, our final exam is Monday the 14th from 8:10 to 10:40. Please notice the starting time is 8:10, not 9:10. Okay, so you get 2.5 hours, provided we start at 8:10, and you get until 10:40 to submit the final exam. Of course, for the final exam, there's no homework to turn in. So just prepare by studying off the old exams. Okay. All right, so what I'm going to do is I'm going to knock off the rest of the evens, I think, and then I'll stop and then let you ask questions, okay, on anything from 5.2 to 5.4. So normally I'll let you have Thursday. You're going to get all of Thursday tomorrow and probably quite a bit of today too. Okay. All right, so here we go. Okay, so last time I believe I left off at problem 10. If I didn't, then somebody holler and scream at me to do it again. Okay, but 10, yeah, I'm pretty sure I did 10. Find the half-life of radioactive something, yeah. Okay, so 12. The population of the world was approximately 6.3 billion in July 2003. Assuming the population will grow by 2% in 1 year, estimate the following. When will the population of the world double? B, when will the population triple? So I'll just do part A, and I'll let you do B. The only difference is instead of doubling, you're going to triple. Okay, so my A0 is 6.3. That's the initial amount. And by the way, you don't have to put all the zeros. I'm just going to put 6.3. So A0 being 6.3, and the understanding that this means billions. Okay, yeah, these are billions of people. So you don't have to go 6, 3,000,000. Just say 6.3, and we know we're talking about billions. And that's the calendar year 2003. Okay, and the growth rate is 2%. Okay, so the K is 0.02. They're already telling you 0.02. Okay, so when will the population double? All right, so here's the key information. A0 is 6.3. That's the year 2003. K is 0.02. So plug into the formula. A of t is A0 e to the kt. A0 is 6.3. It said double, 12.6. Okay, I'll just tell you for triple, 6.3 times 3, 18.9. Otherwise, the math is exactly the same. Okay, so for part B, triple means 6.3 times 3, which is 18.9. So instead of putting 12.6, which is double, put 18.9. All the algebra is exactly the same. Okay, they told me the K was 0.02. Okay, divide both sides by 6.3. This is 2, no big surprise. We knew it was going to be double. ln both sides, natural log of 2. natural log of e to the 0.02t. We know this cancels out, 0.02t. Okay, so t is equal to ln2 divided by 0.02. That's about 34.66. I'm going to round it to 35 years. Okay, and then a little extra thing in the problem, because it does say when. When would seem to imply an actual year, a calendar year. So calendar year where 2003 is the beginning of the experiment, so to speak. Okay, so we're starting off the experiment in 2003. So they're saying add 35 years. So 2003 plus 35 is the calendar year 2038. Okay, so that's what they want for that. So that's my answer. Okay, part B, triple, again, instead of 12.6, put 18.9, but do the exact same math. Okay, and I'll digress just a moment, talk a little bit more about the calculator. Okay, so some of you weren't sure about your calculator. So I have a graphing calculator. It's a TI-85. It's actually a very old graphing calculator, but it still works. Okay, so ln2 divided by 0.02. So I'm going to hit ln2 divided by 0.02. I hope you can see that. 34.657. I rounded it up to 34.66, as you can see there. Okay, and then in other words, some of your calculators, once you hit ln, it automatically gives you a left paren. In other words, it looks like that. Okay, so if your calculator automatically gives you a left paren, then you have to close it with a right paren, that's all. So if your calculator goes like that, then ln2 close parentheses, and then the rest is the same, divided by 0.02. And of course, you get the same thing. All right, so that should work for any of the TI series. Okay. Now, if you have a regular scientific calculator like this, then you folks would have to go backwards. Okay. So what do you mean by backwards? So you folks would have to do 2ln instead of ln2. So some calculators are like that. Just experiment with your calculator. I mean, it's either going to be ln2 or 2ln. I can't think of anything else it could be, right? You're either going to go ln2 or 2ln. For this regular scientific calculator, you actually have to hit 2 first. So 2, and then I hit ln, which is over here. Okay, so that 0.6931, that's ln2. And now I will divide it by 0.02. So divided by 0.02 equals, and of course you get the same thing, 34.657, blah, 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 blah. Okay, so just to warn you, some of these calculators you have to go backwards. Okay, and that would work for any of these functions. So this calculator, you have to do the sine, cosine, and tangent backwards. Like if you want the sine of 5, you'd have to hit 5 sine, and so on. Okay, this is a backward type of calculator. Okay, so just experiment with your calculator. If you're not sure, send me an email, or we can talk about it during office hours or something like that. But that's how something like that would work. Okay, so that is problem 12. And I didn't do part B, but you know what to do, right? Just change the triple to 18.9. Is that right? Okay. So let's see, that was 12. Okay, 14.
You already did 14 yesterday.
Let's see.
Mr. Hom?
Yeah, question?
We already did 14 yesterday.
I'm sorry?
We did 14
We did
yesterday.
14, you're right. Okay, I was just noting that. So 16, right? So 14 was the 25,000 thing? Yeah. Okay, so 16, I guess we'll be done faster. Okay, the parents of a 3-year-old child put $20,000 into account. Okay, so that's the initial amount into an account with the hope that the amount will grow to 120,000 when the child starts college in 15 years. Okay, so let's see what we're plugging in. Initial amount, new amount. So this is the left-hand side. This is A of T in the formula. And what do you think that is? Time, T. Okay, what rate of continuously compounded interest is necessary for this goal to be met? So we're trying to solve for the rate. Okay, so way back up here, This is going to be 120,000. 20,000. They said the time was 15 years, and then solve for K. What is the interest rate that I need in order for this to happen? Right? And yeah, the 3-year-old, you don't plug into 3 anywhere. I guess that means in 15 years, that student's 18, so they're ready to start college. Okay, so we invest 20,000. We wanted to grow to 120,000. Time is 15 years. And what is the interest rate? Okay. So here we go. And let's see, where did I put that one? Yeah, right down here. And yeah, after this, I guess I'm done, right? So I would have literally done all the evens, I believe. But if I miss one, you can ask for it again in case I messed up. Okay, so in a few minutes, I'll be finished, and you can ask whatever you want. Then we can start reviewing for the test. Okay, so A of t is A0 e to the kt. So we said 120,000 goes here, 20,000 e to the k times the time, which is 15. Okay, so divide both sides by 20,000. So this becomes 6. 6 equals e to the 15k. We know the way the game works. ln both sides. ln, e cancel out. ln 6 is 15k. So k is natural log of 6 divided by 15, 0.1195. Okay, but when they ask for a percentage rate, right, that's normally the way it's given in banks and lending institutions, 11.95%. Okay, so ln 6 over 15. Let me just show you that quickly again. So on this type of calculator, it has to go backwards. So let's see, ln 6 over 15, 6 and then ln. Okay, there it is. And then divided by 15 equals the 0.11945. I rounded off to 0.1195 or 11.95%. Usually when you hear interest rates in banks and lending institutions, they would round to 2 digits to the right of the decimal point as a percent. So 11.95%, right? I've heard that. I usually don't hear 11.945%. I don't hear that. I definitely don't hear 11.9450631%. Okay, but 11.95% is more usual. Okay, and if you have this type of calculator, just go as is, meaning literally type ln 6, right? ln 6, and then divided by what? Divided by 15. So divided by 15. And of course, same thing, 0.11945, which I rounded to 11.95%. And there we go. Okay. All right, we're done, folks. I believe I've literally done all the evens. If I'm wrong, you can holler and scream at me to do one of the other evens. Okay, but yeah, question?
Yeah, did you do number 8 yesterday? Because I don't think you did.
Did I do number 8? I'm not sure if I did, but I can do that.
Yeah, could you
Okay.
please do
All
that?
right, so let me blab first a little longer. Okay, so yeah, the nice thing about the system here is that, okay, if I forgot to do something, you can ask me to do it. Okay, so we're here, I'm finished. So we're on the buffer day. So I was gonna give you all of tomorrow to review, but we have, you know, all the rest of today also. I'm done with everything. So half of today and all of tomorrow for just this. Okay. All right, so let me check the chat. I believe I found a way to do it without using the screen share. So yes, here we are. Okay, so number 8 I did not do evidently. Okay, so 5.4 number 8 and 5.4 number 2 also. Okay. I thought we did 2, but okay. And let's see, number 8. Okay, so right now I see 5.4 number 2 and number 8. So let me do those. And if anybody else has more, go ahead and put it in the chat. Otherwise, we're ending early, I guess. Okay, so let me scoot the chat over. Why no, let me minimize the chat. And 5.411 also. Okay. So number 8. paper here. Okay, culture of bacteria doubles after 4 hours. What proportion of the original number of bacteria will be present after 8 hours, after 16 hours? Okay. So this one, there's really not any plugging in to do. You just kind of have to reason it out. So number 8. Whoops, wrong color. 5.4. Okay, so let me write down doubles after 4 hours. Okay, what proportion of the original? Part A, 8 hours. Part B, 16 hours. Right. So you don't really have to plug into the formula. Okay. So amount, time. Start off with A0. Doubles every 4 hours. So that means after 4 hours, 2A0. Another 4 hours, 4A0. Another 4 hours, doubles again, 8A0. Another 4 hours, 16A0. Okay, so the answer to part A is this. Pen just ran out of ink. The answer to part B is this. Right? It doubles after 4 hours, so 4 hours, twice the amount. 4 more hours, double that. 4 more hours, double that. 4 more hours after that. So asking for 8 hours, 4 times the original. Part B, 16 hours, 16 times the original. Right? Okay, that's it for that one. Okay, somebody asked for 11. Okay, the table gives estimated world population, okay, in millions of people. Okay, A, use the exponential model and the population from 1950 and 1960 to predict the world population in the year 2050. Okay, so 1950, 1960. So let me write it down. So 1950, 2555, and these are millions, which means 2.55 billion. Okay, 1960, 3040. And these are millions. Okay, so again, you don't have to put 0.00000. Just do all the calculations and you know that we're talking about millions. Okay, so t equals 0 is considered 1950. So if t equals 0 is 1950, then 2050 would be 100 years, is that right? From the year 1950 to 2050? So t equals 100 for the year 2050. All right, plug into the formula. A of t is A0 e to the kt. Okay, the original amount, if we're starting from the year 1950, 2555 goes here. 3040 goes here, the new amount. E to the k. And now t. What should I put in for t if our experiment begins in the year 1950? 3040 was the year 1960, so I should put here 10. Okay, so our experiment is beginning in the calendar year 1950. Okay, so that means the year 1960 would be 10 years. Okay, so divide 2555 2555, cancel, cancel. I'm pretty sure that doesn't come out nice. Let me just leave it like that. 3040 over 2555 equals e to the 10k. ln cancels out. ln 3040 over 2555 equals 10k. Divide by 10. K squiggly equal. Okay. ln parentheses 3040. By the way, for this one, everybody needs to put the parentheses. So even if your calculator doesn't automatically pop up with the paren, since you're doing this calculation first and then divided by 10, everyone has to have the parentheses there. Divided by 2555 and then divided by 10. So I'm showing you exactly how I'm typing it in. Okay, ln parentheses 3040 divided by 2555, close parentheses, and then divided by 10. Okay, 0.01738. Round it off. Okay, so my formula becomes A of t. Whoops, I didn't want red. A of t is the original 2555 e to the k, which I now know is 0.01738 t. Okay, and now predict the world population in the year 2050. So like we said, we plug in 100 now. T equals 100. 2555 e to the 0.01738 times 100. Okay, and punch that out. So let me try to do that quickly. $14,528 roughly. Million, which means 14 billion roughly. So that'd be the answer to part A. Paper's curling up on me. Hold it down like that for a moment, then you can see the video. And paper wants to pop up on me. Maybe I'll fold it the other way. There we go. Okay. For part B, it's the same thing, so I'd rather not do it if you don't have to. It's the same game as A. Instead of using these numbers, you're going to plug in 1990, so you plug in 5275 and 2006-079. Do the exact same stuff. And then for the year 2050, let's see, 1990, if that's the beginning of the experiment, 2050 would be 60 years. Is that right? So you'd be plugging in 60. I'll just mention quickly, you get different answers. Okay. And you'll hear this all the time when people make estimations like this. It all depends on what model you pick. Okay. Whatever model you pick, you're going to get completely different answers. So when you hear people say, well, I predict so-and-so is going to happen, and then it doesn't happen, you know, so such and such is going to be like this, and such is going to be like that. It all is based on your model, but we don't know if the model holds or not, right? So just watch out when you hear people say in the year blah 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 such and such is going to happen. That's based on a model that's making a lot of assumptions. Assumptions being, okay, this is going to happen, this is going to happen. But a lot of times those assumptions don't happen. So, you know, be very wary when people say, you know, in such and such a year something's going to happen. That's assuming the model holds, but a lot of times models don't hold. Okay, so that is that. Okay, somebody did ask for 2, even though I did it the other day, but that's still okay. Okay, so E. coli. So 1 becomes 2, it doubles in 22 minutes. The initial population is 200 cells. doubles in, forgot what it was, 22 minutes. The initial 200. Okay, so A of t is 200 e to the kt. Double means 400 equals 200 e to the k times 22. Divide 200. 400 divided by 200 is 2 equals e to the 22k. Take the natural log of both sides. ln, that cancels out. ln 2 equals 22k. Divide by 22, divide by 22. So ln 2 over 22. ln 2 divided by 22. 0.03151. So my formula becomes A of t is 200 e to the 0.03151 t. Okay, that's part A. Part B, find the number of cells after 10 hours, plug in 10. Okay, I'll only do it if there's nobody else with a question. But since we already did it before, I'll just give you the highlights. Part C, when will the population reach 10,000? So plug in 10,000 to the left-hand side. And yes, I changed the problem. If you're wondering why the back of the book doesn't match, I changed it to minutes. Everything is in terms of minutes. Okay, not hours. Okay, I didn't like how they switched units. Oh, you don't have the answer in the back of the book anyway, so it doesn't matter. Okay, so I'll only do this if there were no other questions. So let me check the chat again. If I can get that. Here we go. Okay, I was asked to do number 7. I'm assuming it's the same section. Okay, so I'm going to put this on hiatus. So I'm not going to finish this, sorry, but look back in your notes. We did number 2 the other day. Okay, but this is the highlights of it. So just plug in 10 here in your calculator. And here at 10,000, you have to do more work. You got to do the same ln stuff that you did over here. Okay, so 7, I'm assuming it's the same section, so I'll keep going in the same section unless somebody corrects that. Okay, culture bacteria doubles every 2 hours. How long will it take to triple? Okay. So double 2 hours. Well, clearly it's going to be more than 2 hours, but less than 4 hours. Does that make sense? Okay. Because if I take another 2 hours, 4 hours, it would quadruple, which is double, double. So I'm assuming the answer is going to be between 2 and 4, maybe 3 something. We don't know. All right, so here's how you do it. For this problem, they never give me the initial amount. We don't need it. So double the initial amount. So what's double A0? 2A0. E to the K and 2 hours. Divide by A0. It's gone, right? 2 equals E to the 2K. How do you get rid of the E? ln. Same old stuff. ln2 is E to the 2K. Oops, I'm sorry. I got rid of just 2K. That's what I want. Divide by 2. So ln2 divided by 2. ln2 over 2. 0.34657. Okay, plug that back in over here. So my formula is A of t is A0 e to the k, which I now found to be this thing, 0.34, whoops. Oh yeah, that's right, 34657 t. Now, triple 3A0 equals A0 e to the 0.34657 t. Okay, so this is because it says triple the original. Okay. Same thing, divide by A0 and it's gone. Okay, so I reached the bottom of my paper, so let me copy on top. 3 equals e to the whatever. Okay, so I'm going to go back up. 3 equals e to the point whatever, 0.34657 t. Can you guess why I leave a space there? I'll leave a space so I can write ln. Right? After a while, these problems all work the same. Once you get the hang of it, you do 4, 5, 6 of these, then you got the hang of it. Okay, they all work the same way. You always do this, ln, cancel ln, blah, 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 right? ln 3 is 0.34657 t. Divide by 0.34657. 0.34657 cancels out. And my units are going to be in hours. So t equals blah, blah, blah hours. Okay, check, can I have fractional or decimal hours? Yes, you can. You don't want fractional people, fractional bacteria, or something like that. Okay, so let's see, ln 3 divided by my answer, 3.1699, call it 3.17. 3.169925. So round up 3.17 hours, or 3 hours and 10 minutes, roughly. And a quick double check, yes, it does agree with our first intuition that it should be between 2 and 4, right? Because if it takes 2 hours to double, then after 2 more hours, 4 hours would be quadruple, 4 times the amount. Since we wanted 3, I guess it would be 3 hours something, and it is 3.17. Okay. All right, let me see if I can check the chat again. Okay, looks like I've caught up with the chat. Yeah, I've caught up with the chat, in which case I'll go ahead and finish number 2 then, I guess. Okay, so unless anybody else has anything else, we'd be done. So let me go back and finish this. So cut across here, I guess. So A of 10, I just plug in 10. 200 e to the 0.03151 times 10, which is 200 e to the 0.3151. And let's see, this is bacteria. So bacteria round to the nearest whole number. 200 e to the 0.3151. 274. And then part C, plug in 10,000 right here. 10,000 equals 200 e to the blah, 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 0.03151 t. Divide 200, divide 200, that cancels out. You can cancel 2 zeros. 100 divided by 2 is 50. 50 equals, leave a space, 0.03151 t. Same old stuff. Get rid of e with ln. These cancel out. Natural log of 50 again. ln stands for natural log or log natural. Equals 0.03151 t. Divide both sides by 0.03151 and we're done. 0.03151, 0.03151. T, time, can I have fractional time? Sure. So time, I'll round to the nearest hundredth. And this is going to be in minutes. So minutes. Okay, so what is it? ln 50. Yeah, I'll show it to you with the backward type calculator, the standard scientific calculator, in case you have this type. So you folks would have to hit 50 ln first. So 50, and then hit ln. Where's my ln button? Here it is. Okay, so that's ln 50, and then divided by 0.03151 equals 124.15, roughly 124 minutes, which you would say 2 hours and 4 minutes, a little bit more than 2 hours. Okay. All right, and I think I'm caught up. Okay, so anybody else with a question, you can either unmute yourselves or put it in the chat. Otherwise, we're done for the day, folks. Okay, I don't hear anything. So tomorrow, you can have the entire time for questions and answers, and Friday's the exam. Okay. All right, have a good day, everybody. We'll see you tomorrow. Okay, bye.